Okay, this is exam one's problem number 6, and the way that this problem was supposed to have been approached was to actually use the calculator. You can do this by using y equals mx plus b, but the section 3 was actually to teach you how to use the calculator to do your linear model. So what we have here is we have a set of data, and we have a TI-83 calculator. This works pretty much the same on the 84, except some of the screens will look a little different. And what we're going to do is we're going to enter the year data into list 1 and the tuition and fees data, because my table got cut off a bit, that's going to go in list 2. But when we enter the data in list 1, what we want to do is we want to let the base year be year 0. So basically that's what it means when it says let t correspond to the number of years after 2000. That means in 2000, t is equal to 0. And similarly, in 2013, t is equal to 13, and so forth. So we're going to put the data into list 1 in the calculator. So I'm going to turn it on, and I'm going to clear my home screen. And where we put the data in the calculator is we press the Stat button. On the Stat button, we're going to edit the lists, because this part of the calculator is like a spreadsheet that we can put tables of information in. So we're going to press enter while the calculator has list 1 selected. And here my list has a bunch of data in it. So what I'm going to do is just sitting at the top of the list in the first entry, I'm just going to press delete. Until all the data just disappears. And then I'm going to go over to list 2 and do the same thing. Now there is another faster way to do this if you have data to remove, but I would rather address that with you when we need to cover this again sometime. So for now, we're going to start in list 1 and list 2. And in list 1, our entries are going to be 0 for the year 2000, 2 for the year 2002, 4 for the year 2006, 6 for the year 2006, 8 for the year 2008, 10 for the year 2010, 12 for the year 2012, and 13 for the year 2013. Then we're going to go over to list 2, and we're going to enter the tuition and fees for each one of those years. So in 2000, the tuition and fees was $16,700. And I want to double check, because when I increased the font, my table lost some information. So I want to make sure that's right. So I'm just briefly going to go back here and look at exam 1. Okay, and I notice here that all of my data is not showing. So I will go with this copy of exam 1 to get my data. So let me get the calculator here. And so it should have been $16,078 for 2000. 2002 should be $18,061. And 2004 should be $20,049. And 2006 should be $22,307. 2008 should be $24,816. 2010 was $26,767. 2012 was $29,989. And 2013 was $30,099. So now that we have the data appropriately recorded in the calculator, I'm going to have it calculate the regression equation. And as I said, the TI-84 is a little bit different, but not very much. We're going to go back to the Stat button and go over to Calc, and we're going to choose number 4, which is linear regression. In other words, it's going to fit a straight line to that data. And we're going to hit the Enter button. And then we need to tell it which 2 lists we have that we're working with. So mine is going to be second 1 for L1. Then we're going to enter a comma, which is right above the number 7 key. And then second and the number 2 key for list 2. And if you want to do this in an automated fashion, you can also add an additional comma on the TI-84. This would have said the X list, and you would have told it list 1, and the Y list was list 2. And then the next thing it might tell you was a frequency. You would skip over that. And then if you want to enter the regression equation or store the regression equation, this is where you would do that. And to do that, you want to press your VARS key and move your cursor to the right arrow to YVARS. And we're going to use a function, so we're going to press Enter. And we want to put this equation at Y1, so I'm going to hit Enter a second time. And then we're going to hit Enter to complete the calculation. So what this tells me is that if the model is going to fit a linear model, and I'm going to skip down to item C at this point, if this actually is going to fit a linear model, then our linear model C of T, which is the tuition and fee, the cost of tuition and fees in year T, where T is the number of years after 2000, is going to be, the slope is 1122, and since this is in dollars, we're going to put 0.65, or 0.658 rounds to 0.66. T is the number of years, and in year 0, our tuition and fees should have been, based on the model, about $15,802.47. Now notice I said should have been, because it may not match the actual year 2000 for the data, but this is basically saying that in year 2000, the model says that the amount of tuition and fees would have been $15,802.47, or approximately $15,800. Now, where the problem says include the units for both variables, C is measured in dollars for tuition and fees. And this is going to be T years after 2000. So this is your equation for your model, and this is your units for your model, and you have to have both for the complete model. So when I ask you for a model, you want to be sure you got all of that. So now let's return to parts A and B. And part A says to sketch a graph. Well, sketching a graph shouldn't be too tough. And I'm going to try to make this as simple on myself as possible by saying I'm going to scale these years to where this is the year 2000, this is 2002, this is 2004, 2006, 2008, 2010, and this would be 2012, and this of course then would be 2013. So in the year 2000, the tuition and fees was approximately $16,000. Now I need to go from $16,000 up to $30,000. So if I let this be, let's see, if this is 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30,000. So let's start this where 15 is actually at the axis, which means we're saying that this is not going to be 0, 0. This is actually going to be -1, meaning that's 1999 rather than 2000. So in 2000, we should be at approximately $16,000. I'm not going to try to make this perfect. And then in 2002, it should have been around $18,000. So there's $15,000, $16,000, $17,000, $18,000. And in 2004, it was right at $20,000. So 15, 16, 17, 18, 19, 20. And then in 2006, it should be at 22,000. And in 2008, it had gone to almost 25,000. So this is 22, 23, 24, not quite 25,000. Let's make sure I counted that right. No, sorry. That didn't go there, so we're going to get rid of that. I put it in the wrong place. Teachers make mistakes too, as you notice. So we'll get rid of that one. There, I believe that's better. So now we're ready to do 2010. It looks like 2010. I'm going to scoot over a little bit so I can see better and reach better. 2010, the tuition and fees was almost 27,000. So here's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, but not quite 27. And then in 2012, it was almost 29,000, very, very close to 29,000. So that's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29,000. And then in 2013, it was 30,000, almost 30,100, but 30,000 will be close enough. So we look at those dots, and what we see in answer to the question that we're being asked here then is, does the data seem to follow an approximately linear pattern? And yes, actually it does. If I were to try to draw a straight line through this data, I can see that a line is a reasonably good fit for that data. So yes, a linear pattern seems to be appropriate because all the points lie very close to a line with a positive slope in this case. Because we notice that as the year values increase, so does the tuition and fees, and that happens at a pretty close to constant rate. Now, given that we have established that, then we go on to discuss part C, which we've already answered. And that linear pattern does indeed have a positive slope. This is your slope. And your slope is $1,122.66 per year T. That's your slope. And what that tells you then is that the graph indicates that the annual cost of tuition and fees at the colleges is increasing, because it appears to be increasing. So not decreasing. We would select increasing. By about, now you could, about, well, $11,022.66 is pretty precise. The model is very precise, but the truth is the tuition and fees are actually increasing by about $1,100 a year. Now, if you got more precise than that, I'm not going to count off, but the word about says you probably don't want to give that to exact dollars and cents. You want to be ballpark. And then part C says, discuss the accuracy of the model using this equation to estimate the cost of colleges in 2005. And this one says, because all the parts are scattered at random, an estimate would not be accurate. Well, they are scattered at random, but they have a very definite pattern, so no, that's not true. And the same thing, part C, because all the lines lie on a curve or a V-shape, an estimate would not be accurate. Well, they didn't lay on a curve, and they didn't make a V-shape. So that's not the correct answer either. The truth was the points all lie close to a line. An estimate would be accurate. So then the question is, what was the estimated cost of college in 2025? And that would be the slope of the model, 1122.66, or we could use 1100, times, in 2025, that's T is equal to 25 years since 2000, plus $15,802.47. And keeping in mind, it would have been okay to use 1100 here and 15,800 here. That would have been fine. But we're going to stick with the equation we got, and I'm going to show you how to finish out this problem on the calculator. So using the calculator, we're going to go back, and I've got to turn mine back on because it turned itself off, being very helpful trying to save my battery. But since it's on the computer, that really doesn't exist. And then I'm going to go and press my second y equals button because I want to see this scatter plot. So second y equals takes me to the stat plots. And on plot 1, I'm going to select plot 1 by pressing enter. And then I'm going to press enter again to turn plot 1 on. And I want to be sure that my cursor is on the scatter plot. That's the first graph. And my X list should say list 1. And my Y list should say list 2. And I'm going to let it make the little square boxes for the marks because it's a little easier to see, especially for you, than these little tiny dots. So we've got it set up now to turn the scatter plot on, but we need to set the window. Now we could go back to the data to set the window, but your calculator has a feature on the zoom menu that if you'll scroll down to zoom number 9, because we're using the stat button, this button and stat plots are connected to zoom stat. If we choose that option, what your calculator is going to do is it's going to set up a nice graphing window so that you can see the points on the scatter plot. And because we've stored the equation at y equals, we're also going to be able to see the equation of the line and see the picture of the line. So I'm going to choose zoom stat by pressing enter with that selection. And here we see what the scatter plot looks like. And you see that the scatter plot looks very much like the one that we drew on our graph paper. And if I would like to know what the value is at 2025, I look on my window and my window doesn't go up to 25 years after 2000. But if I increase that 14 to 26 so that I can see 25 and then hit graph again, notice that I've given myself the option of being able to see, although it's beyond my view at the top, I'm able to see the window with x equals 27 on, or 25 on it. So what I'm going to do is I'm going to hit my second button, my trace button. This is the calculate menu for your graph. And I'm going to choose value by pressing enter. And I want to know in the year 2025, what would the tuition and fees be? So I'm going to hit enter. And it says, well, in the year 2025, tuition and fees would be approximately $44,000. The exact figure given by the model is $43,868.94. But here again, because it's an approximation that we're using, it would have also been equally appropriate to say that it was about $44,000. So I wasn't really looking for the numbers there as much as I was looking for process. If you have questions, please let me know. I'll be glad to work on other problems for you if you need them, and help you get ready for the next test.